Hello everyone, my name is Pabitra Mandal from Electronics and Communication Engineering and from Coachbihar Government Engineering College. Our project is IoT project uh, for a smart fan controller, and our teammate is the sixth member of our project. Thereafter, the project is introduction of this project is mainly in day to day there are various necessities of common man. Internet of things is going to play a vital role in applications such as smart home, smart cities, industrial, internet, healthcare system, etc. This project presents a smart fan control system that automatically adjusts fan speed based on room temperature and humidity. It is used an ESP8266 microcontroller and DHT11 temperature and humidity sensor and an IR sensor for RPM measurement. The system support manual control via a mobile app using the Blynk IoT platform, offering flexibility alongside automation. Real-time data such as temperature, humidity, fan, RPM, and PWM values are logged to the ThinkSpeak cloud for remote monitoring and analysis. And after that, the aim is this project is to design and implement a smart fan control system using the ESP8266 microcontroller that can automatically and manually control the speed of a fan based on a real-time temperature data with additional features such as remote monitoring, manual override via Blynk IoT app, and RPM logging to ThinkSpeak for data visualization and analysis. This system aims to improve energy efficiency, provide user convenience, and demonstrate the integration of IoT technologies for intelligent environment control.
Hello everyone, myself Biswarup Pal from Electronics and Communication Engineering. So here are the components of this project. There are two types of component, hardware component and software component. There the firstly we have discussed the hardware components. There are ESP8266 NodeMCU. There are the 12 voltage DC fan, MOSFET, DHT11 temperature and humidity sensor, IR sensor which is called infrared sensor. There are jumper wires. Okay, then we move to the next slide. There are hardware description of this project. First, we have to discuss the ESP8266 node MCU, which acts as main controller, which is with built-in Wi-Fi for IoT communication. There are DHT11 temperature and humidity sensor, which measures the ambient temperature to control the fan automatically. There are the 12 voltage DC fan, which speed is controlled based on temperature or user input. There are infrared sensor, which is used for measuring fan RPM by detecting rotation pulses. There are MOSFET, example as IRF 540N, which is act as switch to control the fan based on PWM, pulse width modulation from ESP8266. They are the power supply at last to drive the fan and power the system. Okay, next we move to the next slide. Software component. So there are some software components like as Arduino IDE for writing and uploading the code to ESP8266. There are Blynk IoT app for remote control and monitoring via smartphone. There are the platform like ThinkSpeak platform for cloud-based data logging and real-time visualization. There are some libraries which is used to build the project. Those libraries are ESP8266 Wi-Fi.h headers, Blynk simple ESP8266.headers, DHT.h and the ThinkSpeak.h. Then we move to the next slide, which is up to the next member of my team.
Hello everyone, I am Subhankar Paul from Electronics and Communication Engineering Department. I am discussing the block diagram. DHT11 temperature sensor connected to NodeMCU, Blynk IoT connected to NodeMCU, MCU connected to MOSFET PWM, and MOSFET connected to fan and NodeMCU connected to ThinkSpeak, and DTH11 room temperature controller sensor, and it is the.
Hello everyone, myself Prosenjit Biswas, student of Electronics and Communication Engineering Department. Now I am explaining to circuit diagram in my project. Here you can see we used a microcontroller ESP8266. There are 30 pins. We used 3 data pin and we connect DHT11 out pin with D4 microcontroller and positive pin with 3 volt and negative pin connect common ground. Next you see the IR sensor out pin connect with pin D3 and VCC connect with 3 volt and ground connect with common ground in the microcontroller. Now MOSFET gate connect with D1 pin microcontroller, drain connect fan negative and source connect common ground. Now you can see fan positive pin and connect with 12 volt power supply. Here you can see the virtual and physical circuit diagram.
Hello everyone, myself Ramen Samanta from Prof. Engineering College, Electronics and Communication Engineering Department. Now it is the program portion of our project. Firstly, we define the Blynk IoT template ID and Blynk IoT template name. We named Blynk IoT template fan controller. Next, define the Blynk IoT authtoken. Next, we define the files. This file must require firstly include ESP8266 Wi-Fi.h. This is for Wi-Fi portion. Then next, Blynk sample 8266. This is for Blynk IoT. Next, DHT.h. This is for DHT11 sensor. Next, ThinkSpeak.h. This is for ThinkSpeak. In ThinkSpeak, we can see the temperature and RPM graph. Next, define the DHT pin, DHT type, fan pin, IR sensor. Next, we can define the Wi-Fi name. As you can see, the Wi-Fi name is just 5G and password you can see. Then we can. Next, we need to connect our ThinkSpeak to our controller. This is the ThinkSpeak channel number and the API key. The API key must required for connect ThinkSpeak with ESP8266. Here you can see the graph of our temperature and RPM and PWM. Next, for DHT portion, DHT pin, DHT type, Wi-Fi client. Next, we initially fan speed 0 and RPM initially 0. RPM count as initially 0. Then auto mode. For auto mode, if auto mode is true, then fan works automatically like sense DHT11 sensor and fan spin according to our temperature according to threshold volt. And if auto mode is false, then fan control manual. We can manual control using the Blynk IoT. Next, this is void version for RPM count by the using IR sensor. Next, for Blynk switch virtual pin, then we use virtual pin V0, V1, V2, V0 for V0 virtual point for auto mode, control auto mode to manual mode and manual mode to auto mode. Then Blynk slider. Using Blynk slider, we can control the fan speed according to us. And next, control fan automatically. Here we previously defined if auto mode, then automatically temperature sense and fan automatically spin according to the temperature. And if it's false, then fan manually control. Here you can see fan speed mat temperature, minimum temperature we can set 31. This is the threshold value. If less than temperature 31, that fan not spinning. If 31 fans spinning slowly, maximum speed is 40. In 40 temperature, 40 Celsius, the fan speed maximum speed. 1023, this is the maximum PWM value. Next, this is portion the RPM calculation. You can see the function of RPM calculator. And then we'll go to the next slide. This is the portion for serial monitor. We can see the serial monitor. The fan is spinning automatically or manual. We can print the temperature, PWM, RPM in serial monitor. Next, the word setup, pin mode, pin output pull up. This is a function cover, main function cover, our program. This is the call of Wi-Fi begin, Wi-Fi name and Wi-Fi password. Here the time interval 2 seconds for automatically control temperature, correct temperature, then the 15 seconds for the red RPM. And this is the loop for blink and timer run. Thank you.